Welcome to mybazaar.com. Now we are going to discuss about the title Threshold Logic Computing Memristive-CMOS Circuit for Fast Fourier Transformation and Vedic Multiplication. Now we are going to discuss about the abstract of this title. The process in VLSI implementation of brain-like logic gates in the scalability of the networks and its partial limitations in solving large variable Boolean logic problems. Thus, the possibility is to apply the threshold logic gates is designing convolutional computing based fast Fourier transformation and the Vedic multiplication architectures. The real-time pipeline FFT architecture have mainly been adapted to address the difficulties due to their properties such as small chip area, high throughputs and high speed operation. So for the memristive based threshold logic gates is designed using this type of fast Fourier transformation Vedic multiplication. Thus the Vedic multiplication architecture reduces the overall power consumption of the circuit and increases the process speed. Then by using this type of transformation and multiplication architecture for the brain-like logic gates to computing threshold logic gates increases the throughput and reduces the area complexity with efficient performance and also reduces the overall voltage and the power consumption of the circuit will be reduced. Now we are going to discuss about the flow of this title. In this flow, the modules are pre-stage transformation process and Vedic multiplication architecture, Radix to based FFT transformation process, post-transformation process. Then finally we have to see the synthesis and the simulation results. So in this pre-stage transformation process, we are given the input data bits. This pre-stage transformation process, real-time communication system is requiring more number of low latency and complexity based 16-point FFT architecture. Radix 2 is an important FFT architecture used in the digital video broadcastings, that is DVB. In the architecture is designed for complex inputs. The number of arithmetic operations becomes approximately double when compared to those which are designed for the real inputs. Then followed to this we are using the Vedic multiplication architecture. So in this Vedic multiplayer, the reduced partial product generation circuits are used. So for that PPG unit, we are using the carry look ahead adder and subtraction architecture. So in this process, the reduced timing multiplayer circuit we have achieved. So by using this type of multiplayer architecture, we are reducing the area complexity and increases the process speed and reduces the delay while occurring in the transformation process. Then followed to this, we are using the FFT, that is Radix 2 based FFT transformation process also reduced. Based on this multiplication architecture, the transformation process will be performed. So this type of circuits will increases the throughput of the overall performance of the circuit. And then followed to this, we are using the post transformation function. So in this post transformation function, we are using the efficient transformation process. Then in the multiplayer architecture, we are using the weighted logic unit. So in this weighted update unit, the proposed FFT architecture is consist of weighted section of 0 to 7 levels in 16-point section. So the weighted update level is followed in this architecture. Then followed to this 32-bit multiplayer architecture. Our work is to modify the 32-bit multiplayer architecture using Vedic mathematics techniques. So this techniques is used to implement the vertical and cross wire equation based process. So first we design a 4-bit multiplication operation and to develop the 8-bit multiplication process using 4-bit multiplication results. Finally, we design a 32-bit multiplier architecture using a 4, 8 and 16-bit multiplication process. So this structure is used to reduce the complexity of the circuit and increases the timing level and performance and throughputs. So finally we are seeing the simulation and synthesis result of this process. Finally we designed adaptive slip 16-bit radix based FFT digital architecture, then to simulate the final 16-point radix based FFT output binary results and to calculate the circuit complexity, power calculation and speed level. Thus in this process we are achieving low power consumption circuit will operate in high and efficient speed. This type of Vedic multiplane FFT based process will increases the throughput of the circuit. Now we are going to discuss about the running procedure of this title. So first we have to click to this FFT Xilinx ISC project. The simulation and synthesis window will be opened. In this window we have seen the simulation and implementation result of this following architecture. This is the programming window of this architecture. So first we have to click to this main, and now we are going to see the simulation result. For that, click to this simulation, then double click to this simulation behavior model. Now the simulation window will be open. In that we are seeing the simulation results of this following architecture. So finally we obtain the simulation results of this FFT based Vedic multiplication operation, Memristive based threshold logics. This is the simulation result of this process. Now we are going to see the implementation result for the following architecture. For that, first we have to click to this implementation. Then give run to the synthesis existing. After running the synthesis existing report, now we have to see the RTL schematic diagram of this architecture. So for that, first we have to click to this view RTL schematic, then give run, give OK. Then give add create schematic, double click to this, then give full zoom to this. This is our RTL schematic diagram of this FFT based Vedic multiplication operation used in this Memristive based threshold logics. Now we are going to see the technology schematic of this following architecture. For that, click to this view technology schematic and give run, OK, and create schematic and give double click to this, give as. This is the technology schematic of this architecture, then give full zoom to this. So this is the overall technology schematic of this FFT based Vedic multiplication operation using Memristive based threshold logics.